Assalamualaikum, my name is INSHYRAH HARLINA ALYEA LAILA binti Mat ARMALUDIN and my metric number is DE220148. I will present the introduction part. This project focuses on controller design in control system engineering, focusing on the modeling, testing and design of controller in MATLAB. The main goal is to evaluate the ability to manage closed-loop system, particularly proportional P, proportional integral PI, and proportional integral derivative PID controller. The project begins with creating a system model in MATLAB, then test the open-loop system and tuning PID controllers using the Ziegler-Nichols technique and simulating PID tuner tool. The assignment then analyzes the outcome and compares the performance of P, PI and PID controllers. The goals is not only to solve difficulties but also to develop a strong understanding of control system complexities and artistry.
Assalamualaikum, my name is IDZHAN bin MARJOHAN and my metric number is DE220147. Now I will explain about the method. This method, we use the simulating in the MATLAB to tune the controller to obtain the transient response result for the open loop system. To design the modeling system, we need the step block, transfer function block and scope block. So we will connect it like the figure below. We will add the gain into the open loop system to use the Ziegler-Nichols step response and frequency response method. To analyze the transient response using the Ziegler-Nichols method, we can refer the table below. From that, we can determine the parameters of P, PI, and PID. Next, we will modify the model to include feedback from the system output to the PID controller as we move to the closed loop system. In order to implement PID auto tuning, manually set gains will be replaced with the PID tuner block that is configured to tune PID gains automatically based on response from the system as shown in the figure below. So that's all for me. Thank you.
Hi, Assalamualaikum. My name is Faidz Farhan and my metric number is DE220082. So now I want to show the tutorial how to get the simulating result using MATLAB. First, create the diagram, step, sum, gain, transfer function, and scope. This is for closed loop. So sum, change the minus, plus minus, gain 1.5. Okay, and transfer function 2 over 2s power of 3 plus 3s power of 2 plus 2s. Okay, next create a diagram for P, PI, PID. Okay, so first PI, so first P, we need to change the value 0.9. Okay, and then click the button tune. And then we will get the result. So this is a block response and tune response, and click the show parameter and then you get the control parameter for block and tune, and performance and robustness for block and tunes. For closed loop, stability is stable, block stable and tune still stable. Okay, next go to the PI diagram. For the diagram, we need to change the value for proportional 0.9 and integral 0.2808, and then click the button tune. Then we get the result. So this is a plot inference rating. For this PI, we get the same block and tune. The plot still same. 16.8%, peak 117, margin 17.3 dB, plus margin 60 degree, and closed loop stability is stable. On next, we go to the PID. Okay, so for PID, we need to choose the value also. Proportional 0.6, integral 0.28, 0.8, derivative 0.7212. Apply. Click the button tune and get the result. Okay, this is a step plot reverse tracking. Get the tune response and block response. So click the show parameter and then you get the result. Control the parameter and performance and roughness. Okay, this is a tune and block. Okay, first for block 0.9. So after click the button tune, you get the block and tune result. The answer is not same but still stable.
Assalamualaikum, I'm QAIYUM and right now I'm going to discuss on the result of our open loop system. So as you can see, the above image shows the open loop system criteria and the picture beside me shows the one we model in Simulink. So the system consists of step input, gain, transfer function and scope. And then by using the system we can then run the open loop system in simulation in Simulink and see the results. So by using MATLAB command, we can obtain the step response graph as shown in figure 5 and also the pole 0 map in figure 6. So this pole 0 map, we can observe out the root for transfer function to secure the absolute number for our poles and 0 of our modeling open loop system.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is FAIZUL HADI bin ZULKIFLE. So today I want to discuss about the results. So as for the closed loop, we can see here is a closed loop which consists of step input, summing junction, gain, transfer function and scope. So when we run this closed loop system and we look at the scope and the graph, as we can see as below the graph. So we can take some value to be used in Ziegler method from this transfer function, which is the gain. We use 1.5 as the gain KCR. We use that value in the Ziegler method. And for PCR, which is the period of oscillation, we can find by we just plot the at the graph peak to peak value, and the time taken is the period of oscillation. That's all for the result.
Okay, so now I will explain about the Ziegler-Nicholas method. This method are the classical tuning methods for PID controllers and that are going to utilize the approaching method to apply to the control system, which is both open loop and closed loop system. The step response method is based on an open loop step response test. So the unit step response of the process is characterized by two parameters, KCR and CPR. I mean PCR. Based on these figures, you can see KCR is 1.5 and PCR is 6.410, and by using the Ziegler-Nicholas method we can obtain the calculated value as for P, which is 0.75, for PI is 0.6 and 0.12, and lastly for PID is 0.9, 0.2 and 0.7. So that's all for the Ziegler-Nicholas method. I'll pass the presentation to the next person.
Okay, Assalamualaikum warahmatullahi wabarakatuh. So for this, we just discuss for the Ziegler method versus we compare with PID auto-tuner. So for the proportional controller, the proportional gain significantly decline from 0.9, which is the value from the Ziegler method. So we put that Ziegler method into the block. So it declined from 0.9 to 0.34738, which is from the PID auto-tuner. So we can see here the graph in my left. So the solid line is the tune response. and the dotted line is the block response. So we can see there's a massive difference between the two graph, which is from the Ziegler method and PID auto-tuner. So when we compare, we can see the system resilience and the performance were significantly damaged by the change made by the Ziegler method, which led to rising and settling times. So when we auto-tuned, we can say that the rising and settling time were much better. Okay, as for the proportional and integral controller, we can see here the proportional gain decreased from 0.9, which is from the Ziegler method, to 0.19125 in the PID auto-tuner, while the integral term decreased as well compared to the Ziegler method, which is to 0.2808 and changed to 0.008656 in the PID auto-tuner. So we can see the graph, the solid line is the tune response, which is the PID from the PID auto-tuner. So when we analyze this graph, we can see there's a small overshoot, and we analyze using specific performance and robustness outcome, such as we can see the rising time is 5.47 seconds, and the settling time to reach the stable value is 55.3 seconds, and the small overshoot value was 16.8%. Okay, for the proportional, integral and derivative controller, when we compare from the block, which is the Ziegler method, we compare to the PID auto-tuner, the value, which is the integral gain, the derivative gain and proportional gain, takes a massive difference, which is the proportional gain decrease, integral and derivative gain also decrease compared to the Ziegler method. So we can see the graph. So the solid line is the tune response from the PID auto-tuner, and the dotted line is from the block response using the value in the Ziegler method. So we can see there's a massive difference between the two graphs. So there's the overshoot. We can say it is a large difference, massive difference in overshoot, which is for 53.5% from the block and 12.7% from the auto-tuner. So, and the rise time and settling time also much slower in the tune response compared to the block response. So when we analyze this, we can see the closed loop stability of the system remain steady, which just shows how efficient this PID controller is. So the rise time, it can react in much quicker and very precise, and also improve the controller settings. It creates more balanced and regulated dynamic response. So that's all from me. Thank you.
For the conclusion, this project has enhanced our understanding of controller design and the intricacies of controller system. Through meticulous modeling, testing, and controller design in MATLAB, we have gained a deeper understanding of the subtleties involved in tuning processes. We have examined the benefit and drawback of PI and PID controllers and compared their relative efficiency. This has provided us with practical expertise in designing and modifying custom-made controllers, enabling us to satisfy the system transient response needs. The knowledge gained will be beneficial for future control system engineering project. That's all for me. Thank you.